Let's continue with the second half of the video. So we've done our after 1 day, we've done after 2 days. Now we're being asked in D to find the distribution after, in C, find the distribution after 3 days. So the same process again. After 3 days, that must be our third state matrix 3, and then the day before is obviously the second day, state matrix 2. So 1 less, so that's the 3 minus 1. So here's our third state matrix. That's our transition matrix times the second state matrix. So that's up here. The third state matrix is the transition matrix times the second state matrix. Here's the second state matrix here, S of 2. So we can see we're just using the previous question to help us answer the next question. And we put this in our calculator, and that pops out 53.16 and 46.84. So the difference again is shrinking. We've only gone up by, shifted by about 7 this time. Again, that the amount it's changing is shrinking. Eventually it will stop changing altogether and it will become a steady state. So let's find the distribution after 18 days. That gets a bit complicated because in order to find 18 days, let me write that out for you. In order to find S of 18, we have to find T times S of 17, like the day before. But we don't have S of 17 because we've only found up to S of 3 so far. So to find S of 17, we have to do S of 17 equals T times S of 16. We don't have S of 16 either. So hang on, S of 16 equals T times S of 15. Oh, hang on, we don't have S of 15 either. Let's say S of 15, that's T times S of 14. Oh, hang on, we don't have S of 14 either. So S of 14 equals T times S of 13. And I think you can see we'll keep needing the previous one all the way until we get back to, well, we've got the third one, so we could use that to find the fourth one. S of 4 equals T times S of 3. And we could do that, we could definitely do that. T times S of 3, and we could put in the T there. We have the transition matrix, and we've also got the third state matrix. And then we could do that, we could put in our calculator, happy as Larry, and party time now. We've got 4, then we can find 5, 6, 7, 8, 9, 10, 11, 12, 13, find S of 14, S of 15, all the way to S of 18. I reckon you can imagine that'd probably take 15 or 20 minutes. And it's definitely not worth their while asking that question to us in VCAR to assess that knowledge. It's a small part of the course structure. So they've made a quicker way for us to do it. We can use that second formula that you would have seen on the first page all the way back here at the start of steady state. Do you remember this sheet here? Here's our second formula. We've been using this one up until now. Let's start using this one here. So that's this 18, for instance, is just going to pop up here. Let me show you what I mean. Find the distribution after 18 days. So we're looking for S of 18. And we can say S of 18 equals T times, T to the power of 18, times the initial matrix. That's just the formula there. So 18 days, we're looking for N being 18, S of 18. Find S of 18. So I've written it out here for you. S of 18 equals T to the power of 18, transition matrix to the power of 18, times S of 0. Now obviously that's also quite hard to do, times the transition matrix 18 times by itself, T times T times T times T times T, but the calculator can do that relatively quickly, and that is something that we can put in our calculator. So let me show you what that looks like. S of 18 equals T to the power of 18 times the initial state matrix. Remember we had 80 and 20 as our initial state matrix way back in the start of the question here. S of 0, our initial matrix is 80 and 20. And remember I said it didn't actually matter where they were. It could be 20, 80 or 100, 0, 50, 50. Nonetheless, this is the initial one that we've got in this situation. So there we put that in there. From here we just put it in our calculator. Our calculator can do matrices to the power quite easily. We just pop it in our calculator. So S of 18 equals 25.9974. So we're looking after 18 days like we're getting pretty close to a steady state. But let's really push it out to the max just to check. We're being asked here to find the distribution after 100 days. Obviously after 100 days we've got a lot of transitions, and we'll have to use our calculator for that. So we use that same second formula. S of 100 equals T to the power of 100 times S of 0. And here S of 100, the 100th state matrix after 100 days have passed. We've lucked on our steady state here, 25 and 75. You can see that's pretty close to this one anyway, 25 and 75. Usually, after about 15, I said before, we've got a pretty good steady state. But for example, in this one, we didn't have the steady state after 18 days, not even to the nearest whole number. So, we've found it after 100 days. Yeah, it's definitely the steady state now. How do I know it's the steady state? Well, I checked. I did 150, S of 150 in my calculator, and that said, yep, that's still 25.75. I did S of 200 in my calculator, that was 25.75. We actually reached the steady state after, I think it was about 25 transitions. So there you go. But I think always, just to be safe, if you're asked to find the steady state, push it out to 150, just to really be safe. I've found that when you do numbers bigger than 150, like 1,500, it takes the calculator 10 seconds to do, and who wants to waste 10 seconds or 30 seconds? So 150 is a pretty safe number without having the calculator's brain melt because it's asking you to do so much. So that's a good kind of number. So this is our steady state here. So we started with, way back when at the start of the question, 80 in the first section, 20 in the second section, 100 altogether. We've still got the 100 altogether, but 25 are going to always stay here, 75 are going to always stay here, no matter how many more transitions we do, no matter how many more times we apply that transition matrix. So that's why it's called our steady state. It's become steady on 25, 75. So even if this was 0, 100 or 100, 0, it would still end up having 25 in this first section, 75 in this bottom section. We're going to see how that could be really useful in some application questions in terms of business usage and things like that.